Welcome to Geometry Pre-AP. Today we're going to talk about proofs and actually filling in and doing some proofs today. We will give you all the building blocks on the video tonight so that you can work with those proofs tomorrow in class. So one of our essential understandings is that you can use given information, definitions, properties, postulates, and previously proven theorems as reasons in a proof. Remember that you have to know all your definitions, properties, postulates, and theorems in order to be successful while doing proofs. If you don't know that information, you will not do well with this unit, which will be most of the semester. So adding in a few theorems today, we're going to add in theorem 2-4. So make sure you highlight that in your theorem packet, which says all right angles are congruent. So if you can say two angles are right angles, then you can say they're congruent. So if you have this piece, then this is your next statement right there. Okay, and the reason is, this is our reason right here. All right angles are congruent. So if we have two congruent angles, and those angles are supplements, then we can say that those two angles are 90 degrees. Okay, and this is my reason right here. These two theorems don't have names. Some theorems have names, some do not. So when they don't have a name, we have to remember what the theorem says and not the number. Okay, here's a list of all the different properties that we use in a proof. Reflexive property, symmetric property, transitive, postulates, angle and segment addition postulates, definitions, midpoint, supplementary. So if you want to write this list down, pause the video down. This one right here is a super important one. We're going to talk about that, and of course this is also one of our reasons, the given. All right, so pause the video and write those things down. Now that you've written this list down, you might want to make sure you know the definitions of each of those words too. Make sure it's important that you have those. We've covered those in our notes. So we've covered that on page 18 and 19 in our first packet. Okay, so when you're proving things, you're using the law of detachment that we learned over the weekend. And that is that if you have a true conditional statement, and then you have a true hypothesis that's very specific, then you have a true conclusion that follows that definition or that conditional statement that you have. And this is the basis for all the proving that we do. We use the law of detachment over and over again. When you're done with your proof, you're actually using the law of syllogism, say that from my first statement to my last statement, they all connect together in if-then form to finally make my total and complete proof. And that's what this is saying right here. You could copy this down. It might help you later on when you're thinking about making a proof. Okay, so when you have a proof, you have first, what we have is our baseline. Okay, and so on our baseline, that is just a line that our proof is built off of. It's kind of like a starting point on a race. And so from that starting point, there are only certain things that can come off that line. And the things that can come off that line are down here. These are the things that come off that line. Vertical angles, definition of vertical angles, definition of a linear pair. Remember that those tell you what they look like. They have nothing to do with numbers or anything like that. Segment and angle addition, which comes out of the picture. And eventually reflexive property of angles and segments, which we'll use. Okay. And of course, the given can come from the starting line. Only those things can. Nothing else can. And if you bring anything off the top starting line that's not one of those things, then it's not allowed and it makes a mess for your proof. Okay. This right here is the proof of the definition of symmetric angles. Okay. And so if I have angle 1 and 2, then I can say the measure of angle 1 is equal to the measure of angle 2. That is the definition of congruence. Anytime I go from congruence to equality or equality to congruence, I'm using the definition of congruence. You're going to use that a lot. Make sure you remember that. To go from angles or segments that are equal to congruent or from congruent to equal, it's the same reason, the definition of angle congruence. Now, once I've said those two are equal, remember symmetric properties are property of equality, so then I can flip them, and then I can go from equality back to congruence using that definition of angle congruence again, and now I've just proved that the symmetric property of angles is also true. Okay, what's in your boxes are like your statements. Those are your angles and very specific things. And on the outside is your definition, postulate, and theorems. They're the reason why you can write that answer. Remember that when you're using law of detachment, you might have that if a point is a midpoint, then it creates two congruent segments. And then you have a very specific thing that says B is a midpoint, which would be kind of what you have in a box here. And then your next statement would be that the two parts, AB and BC, are equal to each other. Reason would be definition of a midpoint. Okay? So vocabulary is very important. Okay, so here are some of our fundamental basic proofs. These are the building blocks, and so I'm going to kind of do these for you so that you can kind of see how they work. And so I have a baseline to start here, and so I have B is between A and C. This goes in a box. It's coming off the picture, and it is a given because it's given to me. Notice right next to the word given. And I know if B is between A and C, that's what the segment addition postulate starts like. Remember, if this, then the next statement would be that AB plus BC is equal to AC. Okay, and so in the law of detachment, you have a general hypothesis, and this is my conclusion, and my reason is my segment addition postulate. And so that's how we work it. Now, a lot of times, we won't have the B's between the A and C given to us because we can look at a picture and see if something's collinear, and we can go straight to this without even using given with just saying segment addition postulate. So you won't always see that B is between A and C. We get that from the picture normally. Okay, make sure you have this written down in your notes. It'll be important. Okay, our next one, B is the midpoint of AC. So again, I got my baseline. B is the midpoint of AC. All right, and that is a statement, and that's given to us, and so I can write given next to that. And so if B is the midpoint of AC, then knowing the definition, remember if the hypothesis of a true conditional is true, then I can go with the conclusion is also true, which leads me to AB is congruent to BC, and that is by what? As the definition of midpoint. And I'm abbreviate when I can. So again, have this in your proof. You're going to use these all the time, over and over and over again. These are the building blocks of all the proofs that we do. You just have to use these in different places to do different things. All right, so linear pair postulate. The linear pair postulate, go highlight this postulate in your postulate and theorem sheet, says if two angles form a linear pair, then they are supplementary. So how do we know if two angles form a linear pair? We know this because the definition of a linear pair tells us what they look like. So once you've identified something as a linear pair of angles, so I can say these two angles are a linear pair. Reason why? Because the definition tells me they look like this. Then you can use the postulate to say that now that I've said they're a linear pair, then they are supplementary by the linear pair postulate. So you will have this process here. So after you've said they're a linear pair, you can then say they're supplementary. And then remember the definition is supplementary. Once you say two angles are supplementary, you can say they add to equal 180 degrees. And so what that ends up looking like is like this. Angle ABC and angle DBC are a linear pair. This is what they look like. That's the definition of a linear pair. Two adjacent angles whose non-common side form opposite rays. Remember, it's the picture. Then I can say ABD and DBC are supplementary. Why? Because a linear pair postulate says if I have a linear pair, then they are supplementary. And if I can say two angles are supplementary, then I can say the measure of ABD plus the measure of DBC is equal to 180 by the definition of supplementary angles. So each part leads to another part, which is how the law of syllogism comes in. Now we also have vertical angles. In order to use the vertical angles theorem, you first must say, hey, this is a pair of vertical angles. I have to identify that they're vertical angles. So I have to say these two angles are vertical. Once I say these two angles are vertical, then I can go say that those angles are congruent. And so again, that proof looks like this. Angle 1, angle 2 are vertical angles. Definition of vertical angles. Two non-adjacent angles that are formed by two pairs of opposite rays. There they are. The definition tells me what they look like. And then I can say angle 1, angle 2 are congruent because the vertical angles congruence theorem. Again, have these two written down in your notes. You're going to use these over and over and over again. These are two steps that go together. These three steps over here always go together. These two steps here always go together. You can't have the second one without the first one. You can't have any of these without the one previous to it. They must be there. So have those both written down. Okay, so remember that when you're doing a flow proof, you have given statements, you have something you have to prove. Each statement has something in it that's very specific, and each reason is some sort of definition, partial algebraic property, or previously proven theorem as a reason. You can't just make up reasons, you got to know them. If you don't know them, you can't fill them in. If you make up stuff, it becomes more wrong. All right, so let's look at another one of the building block proofs. All right. And so one of the building block proofs here is that AB bisects CD. So again, I'm going to start off with that information. Do you always have to start off with a given? No, you don't. And a lot of people say you do. And I can prove that false with logic because sometimes people want to start off with something that comes from the picture that can be proven. In this case, we're just using the given, so I'm working with this as a given. All right, so again, the reason for that is given. It's right next to the word given. So I know that if I have a segment bisector, what does a segment bisector do? A segment bisector tells me where the midpoint is. So I know that if AB bisects C, then B is the midpoint. How do I know that? Because the definition of a segment bisector. If it's a bisector, then it finds the midpoint. Definition of segment bisector. And so then I have that. Now, what does a midpoint do? Well, a midpoint creates two congruent segments. So then I can say CB is congruent to DB. And I know these are congruent because of what was right above it. If I have a midpoint, then it creates two congruent segments. So this is definition. Oops, sorry, I didn't mean for that to pop up. Definition of a midpoint. Think about the if then. If B is the midpoint, then CB is congruent to DB. Why? Because the definition of midpoint tells us to do that if then statement. Okay, have this also in your notes. This is important. You're going to use these over and over and over again. And if you build the bank of these, all these are the building blocks for building every proof that we do. All right, and here's another one. All right, so we have angle ABC. Normally, this will not be given to us because I can look at the picture and see I have an angle ABC. All right, and so if I have angle ABC, that's given, and I know if I have an angle and D is in the interior of it, then I can say that the measure of angle ABD plus the measure of angle CBD is equal to the measure of angle ABC. Oops, I don't know why that did all that. Oh, I'm sorry, here we go. BC, okay. And I know all of this is true because part plus part is equal to whole is due to the angle addition postulate. Okay. Now normally I won't have this statement. Okay. Because I can see the picture, and if I can see it from the picture, remember that given statement, segment addition, angle addition can come from the picture because I can see that a point is in the interior and which of the parts and which is the whole. That's the whole point of why we draw pictures in the first place. So again, have this into your proofs. This will be a building block. All right, here's another one. Back to our vocabulary again. Okay, got my baseline always. BD bisects. Sorry, our pen's going a little. Bisects angle ABC. Okay, so I put a box around it. Statements are in boxes. Reasons are on the outside of the box. So I need my little arrow there. BD bisects. That was given to me. And what does a angle bisector do? It creates two congruent angles. And so if I have this, then I create two congruent angles. So angle ABD is congruent to angle CBD, and that's what I was trying to prove here. And so this is by definition of an angle bisector. Okay, and so again, have this in your notes. I'm going to look for all these things. I'm definitely checking the notes on this day because I want to make sure everybody has these things. Next building block. All right, so we have AB is perpendicular to BC, so that makes that a right angle, and DE is perpendicular to EF. We have that right angles. So we want to prove that those two angles are congruent. So AB is perpendicular to BC is a given statement. Now, if they're perpendicular, does that mean perpendicular lines, they form right angles? So that means angle ABC is a right angle. Okay, and that's by definition of a perpendicular line. All right. Well, that's as far as I can go there. That doesn't lead me to anything else. I have to stop there. So then I go and use another given. DE is perpendicular to EF. And that leads me to angle DEF is a right angle. Okay, and so I stop here. Remember back in our notes earlier that theorem 2.4 said that if you have two right angles, then they are congruent. So I can say angle ABC is congruent to angle DEF because all right angles are congruent. Now there's not a name for that theorem, so I write it as a reason. Okay, and so all right angles are congruent, and there I have that proof. Now there are other proofs, but I'm not going to cover those in this video. I'm going to stop this video, have all that information for tomorrow, and then I may go through these other proofs with you guys tomorrow in class.